Bismillahirrahmanirrahim. Unit number 1, complex numbers. This is the course of first year free engineering. In today's lecture, we will discuss the ordered fair form of a complex number, the set of a complex number, and notation for the set of a complex number. That how you can denote the set of a complex number. As we know from the previous videos, that different sets are denoted by different notation. For example, set of natural numbers are denoted by capital N, set of real numbers are denoted by capital R, and so on. So we will see for the notation and the definition in the set builder notation for the set of complex number. Then we will discuss that any power of iota power any number, iota power anything mean iota power any number can be expressed or can be converted to plus or minus 1 or plus iota or minus iota. How we can convert any power of the iota into plus minus 1 or plus minus iota, and then we will solve exercise 1.1 question number 1 and question number 2. This exercise 1.1 is from the first year textbook of Khyber Pakhtunkhwa, Pakistan. So this is the contents of today's lecture. In previous video lecture, in previous video lecture we discussed the definition. Of a complex number, that a number which is written in the form of a plus b iota is called a complex number, where a and b belongs to set of real numbers, that is a belongs to capital R and b belongs to capital R, and iota is equal to square root of minus 1. This notation is given by Euler, to square root of minus 1. This is called imaginary unit. We discussed this in the previous video lecture. Real part of complex number is denoted by Re of z, and this is equal to a, and imaginary part of z is equal to b. This a is called the imaginary part of a complex number, and b is called the imaginary part of a complex number, and a is called the real part of a complex number. Complex numbers are usually denoted by z. So this is a plus b iota. This is a representation for the set of complex number. This a is also called pure real number, and b iota is called pure imaginary number. We already explained this is in detail, that imaginary part, this is real part of complex number z, and this is the imaginary part of complex number z. So imaginary part doesn't contain iota as a factor, but when the imaginary part contains iota as a factor, then this b iota is called pure imaginary number. So there is a difference between imaginary part and imaginary number, pure imaginary number. Remember that both real number or pure imaginary number, both are a complex number, but for the case of a pure real number, the imaginary part is 0. This is written in the form of a plus b iota, where b equal to 0. So this pure number can be written in the form of a plus b iota. So this pure real number is also a complex number. And similarly, b iota can be written as 0 plus b iota. So this is also a complex number, because this is written in the form of a plus b iota. But in the case of the pure imaginary number, the real part is 0. So this is from the previous lecture. Now Hamilton in 1830 gives the ordered fair representation of a complex number. So you see, in 1830, regarded the complex number a plus b iota as an ordered fair form of ab of real number a and b, avoiding the imaginary unit. This mathematician Hamilton represent the complex number a plus b iota in the ordered fair form ab. So according to Hamilton, z is equal to a plus b iota is equal to ab ordered fair form. So this is the ordered fair form of a complex number. Remember, in case of a plus b iota, a belongs to set of real number, b belongs to set of real number, and in this case this is the ordered fair form of a complex number. Here a is also belongs to set of real number and b is also belongs to set of real number, but in the case of the ordered fair form you see that there is no iota, so he avoids the imaginary unit by representing this complex number in the ordered fair form, and remember that every ordered fair is actually represents the coordinates of a point in a plane. So it means that a complex number is actually a point of a plane. Remember that ordered fair is actually represents a point in a plane, 2D plane, two-dimensional plane. So it means that all the complex number will actually make a plane. So the geometrical meaning of a complex number is two-dimensional plane, because the ordered fair form is actually represents the coordinate of a point in a plane. I explained this point a little in detail. Now consider this page is actually a plane. Now I am considering this point. So what is the position of this point? For knowing the position of this point, we are required to draw the rectangular coordinate x-axis and y-axis. So this is x-axis and this is y-axis. So this is called rectangular coordinate system. Now this point is, let's say, a unit distance cover on x-axis and b unit distance cover on the y-axis. In other words, it means that this point is a unit away from the y-axis and b unit away from the x-axis, because the horizontal distance is a and the vertical distance is b. So this point is b unit, this point is b unit away from the x-axis and a unit away from the y-axis. So this is the ordered fair form of this point. Actually this first element of the ordered fair is the distance on the x-axis. So you see that the distance on the x-axis of this point is a, and this second element of the ordered fair represents distance on the y-axis. So actually this AB ordered fair is actually a representation of a complex number a plus b iota in the ordered fair form. So actually this point is a complex number. You see that this point is a complex number. This point is a complex number. Now when you this is your reference point from which you start measurement. So when you join this point with the complex number a comma b, or a plus b iota, which is small z, so this diagram is called ordered diagram. This diagram is called organ diagram. And now this rectangular coordinate system, or this rectangular plane, is called complex plane or z plane. This is actually a rectangular coordinate system or a rectangular coordinate plane. When you plot a complex number in this plane. So this plane is called complex plane or Z plane. So now this in this plane you see that every point, when you plot any point in this plane, for each and every point you must have some ordered pair. So that's why the geometrical representation of a complex number is a plane. So remember that geometrically the set of complex numbers represents the two-dimensional plane. So this is the geometrical meaning of a complex number. Now coming towards the set of a complex number, notation of the set of a complex number and its set builder notation. Remember that the set of complex number is denoted by capital C. Set of a complex number is denoted by capital C, and this is equal to X such that you can write A plus B iota such that A belongs to R, B belongs to R, and iota is equal to square root of -1. R capital C is equal to AB ordered pair. A belongs to R, B belongs to R. Now this ordered pair form doesn't contain the imaginary unit. So this is the representation of a set of a complex number in set builder notation. Remember, this is denoted by C. Actually, geometrically, this C represents a plane, two-dimensional plane, and if you see to this two-dimensional plane, it's actually when you draw x-axis and y-axis, this plane is divided into four quadrants. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. So actually R is equal to C is equal to R cross R, which is equal to R square. This R square means plane. This R square means plane. So this is the geometrical meaning of a complex number. Geometrically, complex number is actually represent a plane. So this is the geometrical meaning of a complex number. This R is the set of real number. R is the set of real number. So in this plane you see that on the x-axis there are also real numbers, and on the y-axis there are also real numbers. So this is R cross R, which gives R square, and this R square represents this whole complex plane. So this is the geometrical meaning of a complex number. Now after that, the geometrical meaning, we will discuss some important relations which helps us to reduce any power of the iota into +1 or -1, or into plus iota or minus iota. So these four important results are based on that iota square is equal to -1, because iota is equal to square root of -1. So when you take square on both sides, so iota square will be equal to -1. Now remember these four equations. Iota for 4k is equal to 1 for all k belongs to integers. This notation is for all. For example, iota for 16, this can be written as iota power 4 multiplied by 4. So when you compare this iota power 4 multiplied by 4 with iota power 4k, so the value of k here is 4, and 4 is a integer. So according to this definition, according to this equation, this will be equal to +1. Or for example, if I write iota power 20, so iota 5 multiplied by iota 4 multiplied by 5. So you see that This is in the form of iota power 4k. K belongs to set of integers. So this is also equal to 1. So please remember this result. Now the second result is, this is 1, 2. Iota power 4k plus 1 is equal to plus iota for all k belongs to z. When you remember these equations, it will become so easy to convert any power of the iota into plus 1 or minus 1 or plus iota or minus iota. So these 4 points, these 4 relations or equations are very important for eta. Iota power 4k plus 2 is equal to minus 1 for all k belongs to z. And for iota power 4k plus 3 is equal to minus iota for all k belongs to z. Now these 4 equations will help you to convert any power of iota into plus 1 or minus 1 or plus iota or minus iota. For example, switching towards the example is iota power, let's say iota power 21. So iota power 21 can be written as iota power 4 multiplied by 5 plus 1. So you can compare this with result, which is iota power 4k plus 1 is equal to iota for all k belongs to z. So now in this case you see that the value of k is 5 and 5 is integer and 5 is integer and 5 is integer. So you can use this result, you can use this equation. So this will be equal to plus iota. This will be equal to plus iota. Now iota power 23. So this is equal to iota 4 multiplied by 5 plus 3. 4 multiplied by 5, 20, 20 plus 3, this is 23. So now this is in the form of 4 iota power 4k plus 3, which is equal to minus iota for all k belongs to z. Mean for any value of k which belongs to set of integer, this result will be equal to minus iota. So now in this case the value of k is 5. This is an integer. So according to this result, according to this equation, this iota power 23 will be equal to minus iota. So you clearly see that when you using these 4 equations, you are converting any power of iota into plus 1 or minus 1 or into plus iota or into minus iota. So these 4 equations are not from your textbook. This is not included in your textbook. Please remember these 4 equations for converting any power of the iota into plus 1 or minus 1 or into plus iota or minus iota, and this will help you and it will reduce your labor. It will reduce the time of solving a question. So these 4 equations are so important for the eta. So remember these 4 equations for converting any power of iota into plus 1 or minus 1 or into plus iota or minus iota. Okay, now coming towards the exercise 1.1, exercise 1.1 KP textbook Mardan board. Now you see that exercise 1.1, this is exercise 1.1, question number 1, iota power 9 plus iota power 19. You need to simplify this. So in this case you clearly see that these questions contain higher power of the iota. So you need to convert the higher power of the iota into plus 1 or minus 1 or plus iota or minus iota with the help of the previous 4 results that we discussed. Then you need to convert minus iota power 23 into plus iota or minus iota or plus 1 or minus 1. And the simplification of these question means you need to convert the highest power of the iota into plus iota or minus 1 or plus 1. And question number 2 is also included in this video lecture. So please remember that there is a printing mistake, that this result is actually equal to minus iota. This is not 0. So please correct this in your books. So these two questions will be discussed in this video lecture also. Now this is question number this is question number 1, exercise 1.1. Simplify iota power 9 plus iota power 19. As iota power 9 plus iota power 19 can be written as 9 can be written as 4 multiplied by 2 plus 1 plus iota power 19 can be written as 4 multiplied by 4 plus 3. So you know two results, that iota power 4k plus 1 is equal to plus iota power all k belongs to z. So this is the value of k in this situation. So according to this result, this iota power 4 multiplied by 2 plus 1 mean iota power 9 is equal to iota from this result, and iota power 4k plus 3 is equal to minus iota according to this result. So this iota power 4 multiplied by 4 plus 3 will be equal to minus iota. So plus iota iota plus minus iota, so plus multiplied by minus you will get minus, so iota minus iota you will get 0. So the simplified form of iota power 9 plus iota power 19 is equal to 0. But don't confuse here that we previously says that any power of iota will be converted into plus iota or minus 1 or plus 1, and actually here you see that the result is 0. So this is not the single powers of the iota. Actually you see that iota power 9 is converted to plus iota and iota power 19 is converted to minus iota, and then this is actually the expression. So when you add that expression you will get 0. Remember that the powers of iota must be converted into plus iota or minus iota or plus 1 or minus 1. So this is the question number 1. Question number 1, part number 1. Now question number 2, part number 2. Iota power minus iota power 23. So this can be written as minus 1 multiplied by iota whole power 23. So this power will be written on minus 1 and on iota power 23. So minus 1 power 23 is odd, so therefore this will be equal to minus 1. It means that you need to multiply minus 1 23 times, so you will get minus 1 because this 23 is odd, and this iota power 23 can be written as 4 multiplied by 5 plus 3. So you know this result, iota power 4k plus 3 is equal to minus iota. So according to this result, k is 5, so this is equal to minus iota according to this result. So minus multiplied by minus plus, and 1 multiplied by iota you will get iota. So minus iota power 23 is equal to iota. This is the part number 2. Similarly, part number 3, this is minus 1 power minus 23 divided by 2. So this can be written as minus 1 power 1 by 2 multiplied by minus 23. Now minus 1 power 1 by 2 whole minus 23. We know that power these powers are actually multiply. So this minus 1 power under the root 2 means square root of minus 1 power minus 23. So this square root of minus 1 is actually equal to iota. This notation is given to Euler, is given by Euler to iota power iota to under the root minus 1. So this can be written as 1 divided by iota power 23, and 1 divided by 23 can be 4 multiplied by 5 plus 3. So 1 divided by minus iota, because this is equal to minus iota according to this result. So this is the simplified form of this. Similarly, you need to solve this. Please see this and solve this. This is your assignment question. This is your assignment. And now moving towards the question number 2. Question number 2 is actually iota power 107 plus iota power 1 1 2 plus iota power 1 2 2 is equal to minus iota. You need to prove this result. There is 0 in book, which is misprint. So consider the left hand side. We consider the left hand side. 107 can be written as 4 multiplied by 26 plus 3 plus this 112 can be written as 4 multiplied by 28, and this 122 can be written as 4 multiplied by 30 plus 2. So now using the 4 result, it's the value आपके iota power 4k plus 3 is equal to minus iota power 4k. This is the value आपके k belongs to set of integer. 28 is an integer, so this is equal to plus 1, and 4k plus 2, so this is the value आपके 30 integer, so this is equal to minus 1 according to these three results we already discussed. So plus 1 minus 1 you will get 0. This is equal to minus iota. So this iota power 107 plus iota power 112 plus iota power 122 mean 120 is equal to minus iota. This is the proof. So these are the exercise questions, question number 1 and question number 2. Please write these exercise question on pages and submit this assignment, all the exercise questions, and submit this assignment on the email, which is Sartaj Ali email is Sartaj Ali std@uop.edu.fk and submit this assignment on this email. Thank you.